Hello and warm welcome back. Today on the bench is the DIY valve tester. It's just an emission valve tester at this point. We've still got a little bit of a way to go. However, we've got most of it done if you watch the other, how many other episodes there is. So this is the front panel. No meters. Just going to be using all my multimeters, my two Fluke 25s and my Fluke bench meter. One of those. They're not working properly, but so I'll have to have a look at them at some point. Anyway, following from the rough plan that I made, which was this, we've got the heater, we've got the bias, that's going to be the screen, this is the anode, and so the bias has got a fine control, as the anode voltage. It's got a fine control. We've got the switch, we've got 4 jacks up the top here, and they basically will plug into the Fluke 25s configured as ammeter. Yeah, so they'll go in something like that with the meter set to milliamps, DC milliamps, and there's 2 of those. One for, and these are for testing double triodes. We've got the patch panel back in. So all we've got is we've got 1 to 9 sort of there, and that corresponds to pin 1, 9 on these valve sockets at the top. And then we've got cathode, anode 1, anode 2, bias, and then that one is for the what do you call it? It's not the screen grid, is it? It's the suppressor grid on pentodes, and that's usually connected to ground, so that would just be connected to ground. And then lastly, although I haven't put them in yet, we'll have a couple of sockets here, and they go to another meter, and they will test with this switch. Where are we? Heater, can be switch, heater, bias, screen, anode voltage. And yeah, we just black, because on the original I'd got like a ground, and then I got 3 other 4mm sort of sockets there, but you only need one with a switch. Some of this will probably have to be modified with the GM when I put this in there, if I put this in there, but I figured I'll leave that till the last. And then looking inside, I've just got a couple of bits of wire at the moment, just because I keep forgetting to get some hinges when I go to town. Got the, where do you call it, installed, the anode supply installed, and if you can see behind that, just pull this Russian ECC83 out the way. Oh, and a 68T, and all this is just running off the big capacitor that feeds the heater, where do you call it, the heater voltage, you know, the heater supply, and that's just a big dropper resistor. So it's a big 120 dropper resistor going into an LM12, and then we've got another 47 ohm resistor, and that just runs the fan at the back there to a nice even sort of spinniness, if you're with me. Speed, that's the word I'm looking for. And then I think that's about it. And then the only other thing I've done is I've mounted this here, which is a 9-pin standoff tag board thing, and that's just to put all the wires from the sockets onto there, and then they'll go from there onto the patch board. What else have I done in here? I think that's about it. Oh no, well, obviously I've wired the back of the panel, and so it's pretty simple. We've got the anode supply, which is this orange and black stripe. That goes to these 2 red sockets here, and obviously that will go through the meter, and then we go back from there, and then that's anode 1 and 2. And we've got our pots. We've got, and this here is basically a big ground bus bar, just makes everything easier. And then we've just got all the sort of little control wires going to the boards. So that's the bias, anode, and that is the heater. So next we need to do the screen. Over the years I've tested, I don't know, I bet I've tested about 20 different high voltage variable voltage regulators, both valve and transistor based. This one was the last one I used, and I can't really figure out exactly what's going off, because it's different to all the other ones that I'll show you in a minute. So basically we've got bridge rectifier. I presume there was a cap in there which I haven't drawn. Got a couple of diodes which I think are where are they? 1N14, is that right? 1848, I can't remember, you know what I mean. So we've got basically two diode drops, which is 1.2 volts. That biases the, this is an MPSA 92, I would have thought on all the time. Right, which I don't understand. So that's going to the gate of the MOSFET. And then, like a lot of other voltage regulator circuits, be it valve or transistor based, we've got a potential divider. We've got 330k there and 20k, and then this is a variable resistor, which I did in the past. However, this is, to me, looks like, all this here looks to me like a constant current source, feeding a constant current to the MOSFET. But that doesn't make sense, because the MOSFET is a voltage regulated device. It's not a current regulated device like a transistor, is it? I mean, I could be wrong here. So I don't really know how the fuck that works. It works okay, but no good as a variable voltage regulated supply, I found. However, I built a couple of modules and I'll just use those just to fix some screen grids on an 807 amp or something like that. Next we've got this circuit here, which was used in the Sussex valve tester, which was designed by a guy called Swordholder on a forum I'm on. He's unfortunately passed away and has gone silent key. However, his work remains. So like a lot of very simple MOSFET based voltage regulators, it's just a source follower, just like a cathode follower or a emitter follower, you know, that sort of thing. Basically the source or the cathode follows the grid. Basically when you adjust the voltage on a MOSFET, that will either let the drain source pass more or less current. So what we've got a potential divider going straight to the gate, and basically whatever voltage is present here through this 470k resistor on the gate, sorry, this is the gate, will dictate how much voltage current is coming out here. And then it's got a simple protection circuit, which is this 22 ohm resistor and a 100 ohm resistor. Not quite sure why that's there, probably, I don't know. Anyway, if too much current flows through this circuit, the voltage will increase around this 22 ohm resistor. This will turn this what is it, an MPSA 42 PNP transistor. That will turn that transistor on, depriving, well, or lowering the voltage on the gate, and thus bringing it back into regulation. It's protected by a couple of back-to-back 15 volt Zeners. So if we get any sort of high voltage transients either this way or on the gate, that will clamp the voltage to 15 volts. Next we've got one that is pretty similar to that, and this is the one that Susie, I can't remember the rest of YouTube moniker, but she kindly sent me this, which I think is her version of Steve Bencher's RAT valve tester, which tests transconductance and GM, I think. Right, so we've got a pretty much similar thing. We've got a 1 mega ohm linear potentiometer here acting as the voltage divider. We've got a 1 meg resistor just to limit current onto the gate of the MOSFET, which is an IRF 320 I think. Also got a 10k, not quite sure why that is needed. Where we had a 22 ohm resistor last time, we've got a 10 ohm resistor, so the same thing applies. If current increases, the voltage drop across this resistor will increase, turning this MPS A42 on and lowering the voltage on the MOSFET and bringing it back into regulation. We've got the same Zener setup as on the last example, however we've also got this additional 100R and 220N. I can only think that that's acting like a snubber to snub any other voltage transients. So this looks quite a good circuit. I'm not quite sure what the 10k is doing there as well. Maybe that's just to decouple it from this 1 meg. I presume that that wouldn't be there if it wasn't for these. So I'm not quite sure. Maybe Susie can comment on that and put me right. Finally, we're getting there, lads, don't worry, we're going to test some valves in a minute, so hold on there, me ducks. Finally we got this, which is the circuit which I've just chucked in the valve tester just to get things working so we can test some valves. Potential divider, 470k resist to drop current on the MOSFET. We've got just one 12 volt Zener to stop any or clamp any transient voltages between the source and the gate. We've got a 3R3 resistor in this case, which when the voltage increases, blah de blah de blah, turns on the BC337, blah de blah de blah. You get the rest because it's the same as the last two examples. Right, let's test some valves. I've got an ECC82 in there. I've got the patch board configured to provide all the correct voltages to the right pins. I've had to sort of bodge it a bit, so this is something that needs addressing in future. I need to make up some more patch leads. I've got my two Fluke 25s reading the current on each anode, and I've got the Fluke 8000A reading all the various voltages. So let's switch it on. I wonder why I couldn't see the heaters glowing. 12.6. Ooh, we've gone a bit over there, old chap. 12.6. Bang on. Next, set the bias. We're on full bias at the moment. Minus 56 volts. We want minus 8.5. Okay, minus 8.9. Wrong way. Right, that's something else I need to sort out. Me fine tuning pot's the wrong way. So if I turn it clockwise it goes down, if I turn it anti-clockwise it goes up. Anyway, there we go. Minus 8.5 volts, bang on. Screen grid, it ain't got a screen grid, so that's at 0. And next, our anode voltage is at 179. This is going to be a problem. I need to address this. We'll get into this though in a later video. I need to set the anode voltage to 250 volts. One moment, I'm getting no readings on the emissions. Let me just make sure I got it wired right. Well, I had it wired right. This valve has got a heater short. I need to have a look at that. Right, hold on, let me just fix the anode voltage. Right, that's 250. There's our emissions of the two triodes. We should have, I just pulled this off the typical operating characteristics. So we should have 250 volts on the anode, minus 8.5, and we should have 10 0.5 milliamps. Well, that one's about right. That one's just a little bit under, so yeah, it's not a bad valve. Next we'll test a Sheldon 12AU7. Got everything set as before. I'll just bung it on. Spin you up there. Just going to run through the voltages just to check. Oh, plus, oh right, of course, you ninky nonk. 12.18, okay, so we need to up that a bit, don't we? Come on, you swine. Yeah, that'll do. Bias -8, -8.5. Screen grid bugger all. That's at 248. We want 250. That'll do for now. And if we have a look at the emissions, we've got 8.7 and 9.4. So yeah, a bit under, but still a, you know, pretty half decent ECC 82 or 12AU7. Next we'll test a 6v6. So heater voltage. What the damn, what is going off here? Jesus. That was a bit bad on my part. It was glowing rather brightly just there. Right, screw up on my part. I've had a few pints, but which is probably why. Just trying to get a video out for you. Oh, come on, right, that'll do. Bias -11. We want -13. Oh, Jesus, Mary and Joseph. Come on, get the handle on the vandal. First time I've used it, so I'm bound to be a bit giddy anyway. -13. Screen grid. 225 volts. Right, I'm just going to leave that there because I'm going to set the anode voltage first. Because we don't want the screen grid just taking too much. Right, the anode voltage should be at 315. Back a bit, back a bit, back a bit. Right, okay, the fine control's doing. Right, I need to change the bias, sorry, the fine control on the anode to, yeah, something different. Right, 315, screen grid 225. Okay, why can I only get 169 on there then? Right, that is rather puzzling. So obviously that's an issue we've got to check. I don't know what the fuck's going off there. Anyway, we're getting some emission, 8.25, 8.26. So let's power off. That was only by way of a quick test. What have I noticed so far that could do with improvement? Sorry, let me just... Right, what could do with improving? For some reason I didn't put on-off switches on each power supply like I did on version 1, which is a stupid omission, because it means that whatever voltage, because the anode voltage is always at 150 volts, it won't go any lower. There's 150 volts on the anode as soon as you power up, and whatever heater voltage that you used when you last tested a valve, which could be 12 volts, which isn't very good for a valve that only uses 6 volts on the heaters. So we need on-off switches. What else do we need? Obviously we need to do the GM board, and we need to have a look at the screen voltage supply, because I don't know what the hell's going off there. and I dare say there's a few other things. Seems to be running cool enough. One thing I did notice on a previous test was that the cases of the 2N3055s felt a bit sticky and a bit rough, which usually indicates like some sort of oscillation or some weirdness going off there. Need to look at the heater supply as well, and sort some of the fine controls as well. So I think that's not a bad result so far. Obviously, yes, I need to build some more leads for the patch panel, and some of these leads are really dire. Some of them you have to pull out with bloody pliers, which is, yep, that needs sorting. So I'm going to wrap this one up here, get some attack for you to watch. Thank you all for watching. Take care of yourselves. Ta-da for now.